All right, so in this lesson, we're looking at 1.5 inverse functions. In blue, it says an inverse just means that we switch the x and the y. So here in green, I gave a little x, y chart. F of x and y are interchangeable. So if we have this chart, we can write the inverse as this, x. And so the little -1 right there shows that this is the inverse. So an inverse is just switching the x and y. So for my first coordinate point, we have 1, -4. That would change to -4, 1. Just switch the x and y. The next one would change is 2, 0, so 0, 2. And the last one would change from 3, 8 to 8, 3. And that would just be the inverse of that initial one. Okay, an inverse just means switching the x and y. So for problem number 1, how do we apply this when I have an equation? Well, the first thing is I want to rewrite it as y instead of f of x. So f of x, I'm going to just put a little y right there. Think of this as y equals. All right. Now I'm going to say, okay, well, an inverse means I switch x and y. So I'm going to switch the x and y. So x equals y minus 3. Right, so x and y. Now I'm going to solve for y. So I switch the x and y. Now I'm going to solve for y. Well, that just means add 3 to both sides. Right? And so those cancel out. Y equals x plus 3. And that is my inverse. So my only step left is just to write it with the correct notation, which is that right there. So I'm going to say f to the -1 of x, which means the inverse function of x, is x plus 3. There we go. Simple as that. Go ahead and pause the video, try numbers 2 and 3, and then I'm going to go over numbers 2 and 3. Number 2, y equals, switch our x and y, so I get x equals -y plus 5. Now I started to make the mistake of moving the negative over there. I'm not moving the negative, I'm just switching the x and y. So that negative in front of the x stays there. I'm just switching the x and y, so that y becomes the negative. Now I'm solving for y. Subtract 5 from both sides. X minus 5 equals -y. I'm trying to get y by itself, so I need to get rid of the negative. We're going to divide by -1. If I divide everything by -1, it's just going to change all the signs. That positive x is going to become -x. -5 is going to become +5. And my -y is going to become +y. Then all I have to do is just rewrite it using correct notation. So inverse function of -x plus 5. Over here, it might look a little scary because there's a fraction, but this one's really not bad. Start off, there's a y, switch x and y. X equals 5 plus 3y over 5. Okay, so now it is a fraction, so it means we're going to start with the outmost, which is that the fact that all of that is being divided by 5. Well, the opposite of dividing by 5 is multiplying by 5. So those cancel out, and I get 5x equals 5 plus 3y. No more fractions. Okay. Well, I'm still trying to get y by itself, so we'll subtract the 5 from both sides. I can't combine the 5x and that -5 because they're not like terms, so that's 5x minus 5 equals 3y. Divide by 3, divide by 3, divide by 3. Okay, there's really two different ways I could write my answer here. I can say it's 5 over 3x minus 5 over 3. Since none of those simplify, I could have just did this. 5x minus 5 all over 3. They're both the same. It doesn't matter. Either way, I do need my f -1 of x. So all three of those were linear functions. Well, what does it look like if I have a root or an exponent in my function? Four. Starting off, same way. Y, and by the way, this is H instead of F, so I'll remember that when I get to the end. Switch my X and Y, so X equals Y solve for Y. First thing I'm going to do is add 1 to both sides. X plus 1. Okay. Now, we have that exponent of 5. Remember, if it was an exponent of 2, meaning it was squared, I would cancel it out with a square root. Well, it's a 5, so I'm going to cancel it out with a 5th root. So a 5th root and that exponent of 5 cancel each other out, giving me just y plus 2. But if I do the 5th root of the right side, I need to do the 5th root of the left side as well. So 5th root x plus 1. Okay, almost got y by itself, just got to subtract 2 from both sides. And so I get y equals -2 plus the 5th root of x plus 1. And then rewrite it. So again, we started off with h of x. So h -1 of x equals -2 plus the 5th root x plus 1. Right? Try doing numbers, pause the video and try 5 and 6. Now I know 6 is a root instead of a power, but they just work backwards from each other. So go ahead and do 5 and 6. We have g, so make sure in the end we write our answer in terms of g of x. Switch our x and y. Need to get y by itself. We'll have a 3, so we're going to do the 3rd or the cubed root of both sides. So that way the cubed root and the cube cancel out, and I get y plus 3 cubed root of x. So need to subtract 3 from both sides. So I'll go ahead and combine steps here a little bit. So there's my g. I'm going to say g -1 of x equals, and it doesn't really matter what order I put it in. We'll say -3 plus cubed root of x, or you could have put cubed root of x minus 3, either way. Number 6, still g of x. There's y. We're going to switch x and y. So just like when we had the fraction earlier, to get rid of my fraction, I'm just going to multiply by 2. 2x equals 6 plus the cubed root of 4y. Trying to get y by itself, so let's first move the 6. 2x minus 6 equals the cubed root of 4y. Well, again, we use the cubed root to get rid of an exponent of 3. So I'm going to use an exponent of 3 to get rid of the cubed root. Okay, so 2x minus 6 to the third power. And no, we're not going to actually do 2x minus 6 to the third power and multiply that out. We're going to leave it just like that. Over here, the 3 and the cube root cancel out, and I get 4y. And then we're really to our last step, because the last step is really just to divide by 4. So that right there is my answer. Say, okay, we start off with g, so g negative 1x equals that right there. All right, so that was power and roots, exponents and roots. Last section is rational functions. What if we have rational functions? Still start off the same way. We have y, so we have x equals 3 over y plus 3 is 1. Need to get rid of the minus 1 first, so we're going to add 1 to both sides. X plus 1, parentheses there, x plus 1 equals 3 over y plus 3. Now I want to get the y by itself, but the y is in the bottom of a fraction. So what we're going to do is multiply by y plus 3. Same thing we did for other fractions. We multiplied by our denominator, and that cancel those out. But if I multiply that side, I need to multiply this side by y plus 3 as well. And I'm not going to actually FOIL those or distribute those. I'm going to leave it y plus 3 x plus 1 equals 3. I know that looks like it's about to be a lot of work, but it's really not. This is why we're not going to multiply those, because I want to get y by itself. If I distribute those to each other, that makes it harder to get y by itself. This is y times something. So I'm going to divide by x plus 1. So those cancel out, okay? And so I know we just went from not having a fraction to not having a fraction to back to being a fraction. The reason why is we're trying to get y by itself. It's okay for x to be over there in the denominator of fraction. I'm trying to get y by itself, and now we're moving closer to getting y by itself. All right, so let's bring this over here. So those canceled out. So all that I have left on that side is y plus 3. On this side, I have 3 over x plus 1. So get y by itself, just subtract 3 to both sides. And I'll say g negative 1 of x equals 3 over. There we go. All right, pause the video and try numbers 8 and 9. Those are the last 3 in that section. Y, switch x and y. X equals 2 over negative y, so that negative stays there. Add 1 to both sides. X plus 1, 2 over negative y minus 2 minus, oh, no. We had 1 to both sides, so that went away. Need to get y out from underneath the fraction, so multiply by the denominator. So I have negative y minus 2, x plus 1, and those cancel out. So over here, I just have 2. Again, trying to get y by itself, so we divide by the other part, in this case, x plus 1. Add 2 to both sides. And I have negative y equals 2 over x plus 1. Okay, but it's negative y. Well, I don't want a negative y, so remember I just divide everything by negative 1. And dividing by negative 1 just changes the signs. So my final answer for this one will be, going back to the original, g negative 1 of x. So that first term right there is positive. So I'm going to set negative 2 over x plus 1. And then this one was positive, so minus 2. Here's y, switch x and y. Add 3 to both sides. Multiply by y. Now there's a negative there. I could put the negative with the y or with the 1. I'm going to leave it with the 1 so I can keep y by itself for the most part. Multiply y over there. So I get y x plus 3 negative 1. And now all I have to do is divide by x plus 3. So g negative 1 of x equals, I can put the negative up top or negative out front, doesn't matter, x plus 3. All right, so that's how we do the equation ones. Now the rest of these are graphs. So let's look at the graphs. Now, you might be looking at the equation like, oh, that's logs, that's scary. We're not even going to look at the equation. So you can just kind of put a little marker through the equations. We don't care about the equation. All we need is the graph. Okay, so we have our graphs. First thing we're going to do, every single one of these, is graph the line y equals x. Remember our parent function, and we want to do it precise. Y equals x is right here. Right? Has a slope of positive 1, goes through the origin. There's the line. Kind of getting off there a little bit. All right. To graph a inverse, all we're doing again is switching our x and y. Okay, and when we do that, we're going to see it flip about that green line. So let's find some points. So here's my graph. I'm going to try to find some coordinate points. Where does it cross? Where does my red graph cross at some coordinate points? I see it crosses right there. Do it in a different color, make it easier. Blue. It crosses right there, and it's kind of hard to tell, but I'm going to assume maybe it crosses right there, at least really, really close. I'm going to write those coordinate points. This is the coordinate point 4, negative 1. This is the coordinate point 2, negative 2. And this is the coordinate point 1, comma, negative 7. Okay. Now, remember, at the very beginning, we said an inverse is just flipping our x and y. So I'm going to take those coordinate points and flip them. So starting with this one, that 2, negative 2, I'm going to flip it, and it becomes negative 2. So that one's going to go to negative 2, positive 2. Just flip the x and y. And let's plot that. Negative 2, 2, right there. Right. How about this one? That point's going to become negative 1, 4. Negative 1, 4, right there. What about this one? That's going to become negative 7, comma 1. Negative 7, comma 1, right there. And then I'm going to graph. Color. It's going to look something kind of like that. Now, again, I got those 3 points correct. Might have been slightly off on everything else. that's okay. Like for instance, I'm crossing the y-axis there, but my actual graph never crossed either of those axes. It just got close to it. So it probably should have been more like that. But again, I'm not too worried about being perfect. Just get those points. And so I know that that's pretty close to what it is. But now look at those. Look at the red graph. Look at the purple graph. Do you see how it's symmetrical? But it's not symmetrical about the y-axis or the x-axis. It's symmetrical about the line y equals x. All inverses are symmetrical about the line y equals x. Another way you could do this might make it a little bit more difficult, so that's why I didn't bother. You see this point here? If I go diagonal, like perpendicular here, that's 2 units. So if I keep going this way, it had to be 2 units. Likewise, if I come right here, that was what, 2.5 units? So it had to go 2.5 units that way. Okay, because it's got to be the same about that line. All right, so I'm gonna pause the video and let you at least try number 2. I realize the other ones might be a little different. So try number 2, and then we'll do number 3 together. All right, so first step, y equals x. So there's my line y equals x. I need to plot some points. So here's a point, here's a point, here's a point. Coming down here, it's kind of hard because it just kind of stays on that line, but say it's pretty close to that. All right, so that's 2, 1, 3, 2, and 5, 3. And down here we had 1, -6. Now, for a couple of those, since they're so close to the green line, it might be easier just to say, oh, perpendicular, that one right there, it's got to come over here to that one. Same deal for this one. It's got to jump over the line perpendicular and go there. And of course, you could just say, oh, 2, 1 changes from 1, 2, 3, 2 changes from 2, 3. Okay. This one right here becomes 3, 5. So 1, 2, 3, 1, 2, 3, 4 right there. And then this one right here changes to -6, 1. All right, -6, -6, 1 right there. And I know that that -6, 1 is just hugging that vertical line. So my graph's going to hug this horizontal line for a while till I get here. See, there we go. The pink and red curves are symmetrical about the green line. All right, number 3. 3 is going to be a little different because when I start drawing this curve, I realize it's also, I have a line tool. Should use that. There we go. So straight. All right, it crosses. Okay, and that actually helps us because if it crosses, then that means I'm going to put a little dot right here where it crosses. I know that's where my inverse point's going to be, right? So I know my inverse has got to be there. So let's find some other coordinate points. Here's a coordinate point, and this one is 2, 5. So I'm going to go ahead and put a point at, well, no, I'm getting ahead of myself. That one is -4, 5. Let's see here. This one right here is -1, -4. Any other points? Well, let's see here. Right there is -3, 0. And right there is 1, 0. Okay, a lot of points for us to use. Let's flip. All right, we'll start off with this one right here. -4, 5 is going to change to 5, -4. 1, 2, 3, right there. So this one right here, 2, 5 is going to change to 5, 2, right there. Let's do this one. -3, 0 is going to change to 0, -3. This one right here, 1, 0 is going to change to 0, 1. And then lastly, color reduced yet. -1, -4 is going to change to -4, -1. So -4, 2, 3, 4, -1 is going to be right there. Okay, so a lot of points there, kind of all mixed together. And draw our curve to connect them. Okay, so here, so I see it's going to go. So I go through the blind there. Let's see, it's going to catch my orange one here, purple, and then keep going. There we go. Not the smoothest curve. Sorry, I'm sure you'll do better, but close enough. You'll see it is in fact symmetrical. My red one and my yellow one are still symmetrical about that green line. It's just a little weird because it crosses. Okay, go ahead and try numbers 4, 5, and 6. We'll try to do something that's a little cleaner. It's not right as much as far as like coordinate points on my graph, right? So here, I'm gonna plot those points where they intersect. I know I got to make my inverse cross at those same points. Okay, let's see here. I'm just going to find some points. I'm going to do, so for instance, this point right here is 0, 2. So that means it has to go to 2, 0. Put that right there. Let's see here. This point right here, I know I'm doing red, so it might be kind of hard to see. +1, -1. So if it's +1, -1, it's going to change from -1, +1. So right here. This point right there is -1, -3. So it's going to change to -3, -1. Should be right here. Okay, let's see if that's enough. So it's coming up like this. It's going to come up like that. Now I need another point to tell me where it goes. So let's come down here. I've got kind of these 2 points right here. So let's plot those 2 in blue. So the first one, that's 2, -6. So -6, 2. And then I have 3, -7. So -7, 3. All right. I'm going to go through there. And then I see it crosses the x-axis right here at almost just under 4. So I've got to cross the y-axis just under 4 as I make my way there. All right. And there is the inverse. That looks a little weird. There you go. come over here to this one. We got a point there. I see here some mirror across there. Same thing here, mirror across to there. And cross is weird there. Let's see here too. Come in this way. Probably didn't do that one quite as well, but fairly close, right? There we go. Symmetrical about the green line. All right, one last graph. It's a parabola, so it should be a little easier. We got this point up there at -3, 2, so -3, 2, 2, -3 right here. It's got to cross there. It's got to cross here. Okay. Let's see here. And that should actually be pretty close to enough for me to get a pretty accurate graph. There we go. All right, any questions, you can always message me on Remind. Hopefully you join the Remind. If not, it's on Google Classroom. There you go. Have a great weekend.